Hello, welcome. Welcome to my YouTube channel. Today we will be starting a new series of class 10th maths. The first chapter is real numbers. So without wasting time, let's start. The first topic of this real number is Euclid's division lemma. Now what is Euclid's division lemma? First of all, who is Euclid? Euclid is also known as father of geometry. And then what's lemma? Lemma is nothing but a proven statement which is used to prove other statements. Now but the important thing is algorithm. That's Euclid's division algorithm. Algorithm is also known as steps. If I will ask you how to divide 27 by 3, you will tell me that first I have to take it as 9 and 27, then minus it, then will come with 0. All the steps are known as algorithm. Now if we explain this algorithm, we'll get to know that A equals to BQ plus R, and A, B, Q and R are all positive integers. Now let's get in the question. Now the Euclid's division algorithm help us to know the HCF of two numbers very easily. How to do that? First of all, let's take an example of NCERT. The question, the 455 and 42. We have to find HCF of 455 and 42 with the help of Euclid's division algorithm. Now, as I told earlier, A equals to BQ plus R. Now, here A is actually the dividend, B is divisor. Here it's clearly that 455 is greater than 42. Then 455 equals to 42 into, now what is Q? We have to multiply 42 with such a number. It's simple division. Now if we multiply it by 10, the remainder will come as 35. Now what we have to do next? Now we have to just continue this progress and to process it in such a way that the remainder, the remainder should come 0. Yes. So for the next step, the divisor here 42 will become the dividend, and here the remainder will become divisor. So let's see, 42 will be dividend and 35 will be divisor. So we will multiply it by 1, then it will be 7. Again there is no 0. Let's continue. Then 35 equals to 7 into 5 plus 0. Yes. Here the situation is the remainder is 0. It means that this all steps are done, and the divisor at this stage will be the HCF of both the numbers. Here 7 is the divisor, so 7 will be the HCF of 455 and 42. Now let's see some questions. The more frequent asked question is that show that any A is a positive integer and it can be expressed in the form of 2q plus 1 or 3q plus 1. Let's see how we will solve such type of questions. Now we have to start, let's write the question first. We have to prove that A is a positive integer, Z is the symbol of integer, and if I will put plus here, it symbolizes that it is an integer, a positive integer. Remember that. Now A is a positive integer and it can be expressed in the form of 2q plus 1 and so on, 2q plus 2, 2q plus 3. Now the question is this much only. So we will use the Euclid's division lemma. It shows that A equals to BQ plus R. So first we will start by letting. Now let A be any positive integer, as I told earlier. Then B equals to 2. Why 2? Because we have to show that it is an expressible form of 2q or 2q plus 1. If the question asked in such a way that expressed in the form of 3q, then we will take B as 3. As per the question, we have to make the changes. So A equals to 2q plus R. Now it means that 0 is let R and then 2. Now what is this? It means that the R of the remainder is either equal to 0 or bigger than 0, but not less than 0. and is less than 2. 2 is B here. Okay na? So it means that there will be two possibilities. Either R will be 0 or 1. Yes na, according to this. So if we'll put R0 in this equation, we will arrive that A equals to 2Q plus 0, A equals to 2Q plus 1. This is the first equation, this is the second equation. Now the question is completely done. Now A equals to 2Q and A equals to 2Q plus 1. It means that A is a positive integer and it can be expressed in the form of 2Q or 2Q plus 1. Now let's start fundamental theorem of arithmetic. Now I hope that you are familiar with HCF and LCM. Now by the Euclids division lemma, we can get to know that because of Euclid only, we can get to know the relation between the two numbers and their HCF and LCM. Now we can arrive at a equation that if A is one number and B is another number and their HCF and LCM, it means that A into B will equals to be HCF into LCM. Okay, so let's do some questions to understand it better. So this is the question. The two numbers are 96 and 404. Now what we have to do is we have to find the LCM. Now first of all we have to get the HCF. So we can get HCF by normal method or Euclid's division algorithm. It's up to you. So we can find by the normal method also. So let's find by normal method. 96 is equals to 2 into 2 into 2 into 3, and 404 is, now this is a pair and this is a pair. It means that 4 is the HCF of 96 and 404. Okay, so we have got HCF, and if we recall the equation, it is A into B equals to HCF into LCM. Now we can clearly find the LCM, that 96 into 404 will be 4 into LCM. Now LCM will be 96 into 404 upon 4, that will be 101 here, and it will be 9696. So 9696 is the LCM of these two numbers, and we found this by using the fundamental theorem of arithmetic. The another important question is, do 6 to the power 9 end with 0? So let's start with very basic. Now we know that if there's a condition for any number with the power to end with 0 is that the prime factorization of that number must contain 2 or 5. Now let's understand it. Let's assume that this number is the prime factorization is 2 into 3. 2 3s are 6. Now yes, so the condition for the 6 to the power n to end with 0 is that the prime factorization must contain a 5 in it. Yes, but if we do the prime factorization, we can say that it is only have 2 and 3, but it don't have 5. It means that it will never end with 0. Now if the same question comes with 25's power n, but here the prime factorization contains 5, it means yes, it will end with 0. Okay, so that's for today. We will do the second part as soon as possible. So the homework is we have to practice each and every question of NCERT. So thank you for watching and giving your time. Please like the video, subscribe, and I will post the second episode as soon as possible. Thank you.